Hello viewers, welcome to this video lecture series on C programming. Today's topic of discussion is on logical operators. So in this session I shall explain you the three different logical operators available in C language. We have the logical NOT, the symbol is in this manner, the logical AND, which is two times you are going to write the ampersand operator, that becomes the logical and we have logical OR operator, it is represented like this. So these three operators, and when you try to see the precedence among these logical operators, logical NOT has got the higher precedence over the logical and logical OR. The second level is given to the logical AND operation, and finally you have the logical OR operation. Here I wanted to tell you, if you have an expression consisting of all these operators, then you are going to check the precedence among these three operators, and the highest precedence is given to the NOT followed by logical and logical OR operator. And the associativity is right to left for the NOT operator, left to right for the logical and left to right for the logical OR. So these things we'll see with examples how you are going to make use of the associativity and also this logical and logical OR and NOT operation. So here I have written in a tabular form. So operand 1 and operand 2, what is the result? Okay, suppose if the operand 1, it is going to give you the result as false, and operand 2 is false, then the result is false. Operand 1 and operand 2, if they are false and true, then the result is false. If operand 1 is true and operand 2 is false, then the result is false. If operand 1 and 2 are true, then the result is true. That means you can check here for the OR operation. And for NOT operation, always the result is in negation. Here I have written one paragraph upon the logical and logical OR. The explanation for this paragraph I'll explain you at the end of this session. Now let me show you few examples with logical and logical OR and logical NOT operation. So first thing, remember logical and logical OR. These are the binary operators. They require two operands. In the table I have written it as operand 1 and operand 2. So as I said, the logical operators treat the operands as a single entity, okay, a unit. So let me write few examples here. Suppose A equal to B, logical ANDed with B less than A. So here let me assign some values. Let us take A equal to some value 8, B equal to 4. Okay, these are the values. Now A equal to B, 8. I'll substitute the values here. Okay, your expression becomes in this manner. How you are going to evaluate? In this expression you have how many operators? One is the equal to operator, then you have the logical AND operator, and then you have the lesser than operator. So relational operators always have got the higher priority over the logical operator. So we have the relational operators equal to and less than. These two operators have got higher priority over the logical operator. Here only one logical operator is there, that is the AND operator, and now you have equal to and less than. This will be at the first level, and then you have the second level precedence will be the logical AND. Now once again in these two, which one you are going to carry out? Because in the previous session I have explained the less than operator has got higher priority over the equal to operator. So first this less than operator will be evaluated. So this 4 less than 8, it is true. So you are going to get it in terms of what? 1, because Boolean 1. Next you have to evaluate this expression. 8 equal to 4, no, it is not true. So you will get 0. Then logical ANDed with 1. Now look here, what is that you are having? You are having in your expression, okay, 0, that is false, logical ANDed with true. 0 logical ANDed with 1, so it is 0, that is false. So this way you need to evaluate the expression. Now let me give you one more example. Suppose you have an expression like this, a greater than b. Let me assign this to some variable s equal to a greater than b, logical ANDed with b not equal to 10, logical ANDed with b less than 12, logical ANDed with a greater than 6. Some numbers randomly I have taken. So and I want to print the result here. Printf, I want to see what is the value that gets stored in s. So what is that it is getting stored in S. Now let me copy down this expression. A greater than B, logical ANDed with B not equal to 10, logical ANDed with B less than 12, logical ANDed with A greater than 6. You are going to first consider the relational operators, because the relational operators have got the higher priority. So greater than operator, less than operator, okay, then you have to evaluate the not equal to operator, then you have next the priority as logical AND operator. Now let us see how to carry out this expression. In this expression, first we have to carry out less than and greater than, and moreover in less than and greater than also, what is that we have seen? Less than and greater than, always the associativity is left to right. That means in an expression, if you have both less than and greater than operator, then your associativity is left to right. So you can first carry out A greater than B. Now so here I should write some values for A and B also. A equal to 10, B equal to 5. So these are the values that we have assumed. Now A is 10, 10 greater than 5, let me substitute. Now start doing this from left to right, because first you have to consider only the relational operators. So relational operators, 10 greater than 5, it is true, okay. So write down as it is. 5 less than 12, yes it is true. 10 greater than 6, yes it is true. So you have completed what? Only less than and greater than. Next you have to look into not equal to. This has got higher priority over the logical AND. 5 not equal to 10, yes 5 is not equal to 10 only, it is true. You have what? All logical AND operations only, and what is the associativity? Left to right. Logical AND also it is left to right. So this is 1. Yes, this is true, this is true. That means this is 1. Logical ANDed 1 with 1 is 1. Then logical ANDed 1 with 1 is 1. The value that gets stored in the variable S is 1. So this is one example. I'll take one more example and show you. Example 2. Let us make use of the OR operation. Suppose in the OR operation you want to store the result in the variable S. A greater than B, logical OR with B not equal to 10, logical OR with B less than 12, logical OR with A greater than 5. So what is that I have done? The same expression whatever I had used for logical AND, I have used here for logical OR, and the values for A and B, A is 10 and B is 5. So let me substitute. B is 5, logical OR B 5, logical OR 5 less than 12, logical OR A 10 greater than 5. First carry out what? The relational operators which has got the higher precedence. So in this, less than and equal, less than and greater than, less than and greater than, 10 greater than 5 true. So true, how you are writing? In Boolean 1, okay. The Boolean constant is 1. Copy down as it is the remaining part of the expression. 5 less than 12, it is true, so Boolean value. True means you have to write it as 1, okay. 10 greater than 5, it is true, so it is Boolean 1. Now this is OR operation, and before carrying out the OR there is one more relational operator here, so you have to first finish this. So 1, 5 not equal to 10, it is true, yes 5 is not equal to. This is your OR operator. There is only one operator, OR operator here, and OR operator has got the associativity left to right. So here you are going to get what? Logical OR, 1 ORed with OR. If both are true, only then it is true. So in this example, what is that you have seen? From here you just start looking into it. 1, that means true ORed with true, you are going to get true. Here also true ORed operation with true, that means this operand 1 is true, operand 2 is true, then the result will be true. So this is what I have mentioned in the truth table also. Whenever 2 operands are true, here in case of OR operator, the result is true. One more example I'll give with the logical NOT operation, which is used to negate the value of the expression. Negating the value of the expression, for example, here I'll make use of 2 variables A and B, and A value let me write it as 10 and B value let me write it as 5. Now suppose if I am writing logical NOT A greater than B. You can let me substitute the value 10 greater than B. So first we have to carry out the relational operator. So 10 is greater than B. B is how much? 5. 10 greater than 5, it is true. If it is true, what is that you are going to write? It will be 1. Now what is that? What is the final expression? Negation of 1 it is. Negation of 1 is what? 0. That means if the operand is 1, the result will be 0. If the operand is 0, the result is 1. Here you can see the operand is 1. So the negation of this is the not operation. So here you will get it as 0. That is false. One program I will write down. See, this is a simple program wherein I have just declared a variable and assigned the value to the variable as 5, and then in the first example I am doing the logical AND operation with 0 but using the logical NOT. Let me see for the first statement, that is for this statement, what is the value? 5 logical ANDed. Suppose any time if this is the expression, remember first thing is you are going to carry out this part only, because logical NOT operation has got a higher precedence over the OR. So negation of 0 is what? 1. So negation of 0 is 1. Now here you are having what? 5. 5 is what? 5 is a non-zero value. Anytime if it is a non-zero value, it is 1. So 1 logical ANDed with 1. That means true logical ANDed with true. The answer is true. So the output in this case will be true for the first one. In second case you have 5 logical ANDed with 0. Now in this case you are simply writing, see, any single character, okay, which is a non-zero will always be true. So it will be 1 here, 1 logical ANDed with 0. Now one operand is true, the other operand is false. So the logical AND operation will be false only. Expressions connected by logical AND and logical OR operators are evaluated left to right, and the evaluation stops as soon as the truthfulness or falsehood of the expression is determined. If you have two expressions, expression 1 and expression 2, in this case what will happen? 10 is greater than 2, it is true. If it is true, Boolean constant is 1. Okay, then logical ANDed with 5 less than 2, it is 0. You are going to evaluate this expression because your first expression has resulted into true. If it has resulted into true, then it is a must that you will evaluate the second expression also to see what will be the overall result. In this case, the overall result is 0. Suppose if you have 10 less than 2, logical ANDed with 5 less than 2. In this case, 10 is less than 2, no, it is not. So once you evaluate the expression 1, your result is what? 0. If it is 0, then anything logical ANDed with 0 is always 0 only. No need to evaluate the second expression. This is what is the meaning of this paragraph which I have written over here. So hope this session is useful to you all. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.